Today in the Physics Funhouse, we're exploring the law of reflection. So grab your mirror, a ruler, a protractor, some pencils, some markers, 3 matte pens, some tape if you need it, a cold beverage, and let's go figure out how mirrors form images. So the first thing we're going to do is take a piece of paper. I recommend graph paper. I'm using a piece of white paper for clarity on the video. And we're going to draw a line down the middle of it like so. Use a ruler because we're going to want all of this to be accurate. And then we're going to take that piece of paper and we're going to put it on top of a piece of cardboard. And the piece of cardboard is there so that we can stick pins in the piece of cardboard. And by pins, I mean things like this. We'll need 3 of them, ideally of 3 different colors. The next thing we're going to do is we're going to take our mirror and we're going to set it in the middle of that line that we drew earlier. What that line tells us is where our mirror is. We're going to want some sort of system for standing it up along that line. Then we're going to choose one of our 3 pins. I'm going to choose the white pin in this case to be the object that we're looking at. And we can stick that in someplace along this side of our piece of paper. And it doesn't terribly matter where. So I'm just going to kind of put it right there. So hopefully it'll stay in the shot. The second pin, let's go ahead and label that pin 1, by the way. So pin 1 represents an object that we could be looking at in the mirror. So that's like the thing we're looking at. Pin number 2, which I'm going to use the brown pin for, goes as close as possible to the edge of the mirror. And so ideally this wouldn't have as big a bulb, if you will, on the end of it, but it will do. A thinner pin would work better because we want it to be flush against the surface of the mirror if possible. Then pin number 3, that's going to be the blue one, we're going to put over here somewhere such that it lines up with the white pin and the brown pin when you look at it through the mirror. So your eye needs to come over here now. We're going to look at the white pin in the mirror and we're going to line it up with the brown pin like so. If you have a pin of considerable thickness like I do, basically you just want to kind of shoot down the middle between the actual brown pin and the reflection of the brown pin in the mirror. So that's going to look something like this. So that when you look through the blue pin, so that's going to look something like this, so that when you look through the blue pen and through the brown pen, it lines up real nicely with the white pen, just like that. Our next step now is to trace the rays that those pins form. So when we do that correctly, our paper should look something like this, where again, the brown pen is pen 2. Just going to label this here. And the blue pen is pen 3. So my next move is to grab my ruler like this, and we're going to trace the ray of light as it moves from pin 1 to the mirror and then reflects to pin number 3. And so I'm just going to line that up with the pen, and I'm going to draw a solid line going from pin 1 to pin 2. And then turn my ruler and draw a solid line going from pin 2 to pin 3. Now I'm not going to move my ruler just yet. And the reason why I'm not going to move my ruler is because my eyeball, which was over here, believes that light travels in a straight line. So to me, my eyeball being over here, pin 1's not over here, it's somewhere back here. And so I'm going to leave my ruler in place and I'm going to trace that ray of light backwards behind the mirror. So, and when we trace rays behind mirrors, we use a dashed line because it's not an actual ray of light. It's where your eye thinks the ray of light came from. So to my eyeball, the image of pin 1 is somewhere over here. The other thing that we're going to do is draw a perpendicular bisector to this angle right here, because we want to measure the angle in compared to the angle out. But we'll do that here in just a second. Your next move is to leave pin 1 exactly where it is, move pin 2 to a new location, and then reline up pin 3 just like we did before. So now pin 3 would be somewhere over in this vicinity. Never move pin 1 because we want the object we're looking at not to be moving around as we're trying to figure out where its image is. We move pin 2 and pin 3 though to get a second set of rays. When you get a second set of rays and then you extend those rays backwards, they should cross somewhere in this vicinity. And where those rays of light cross is where the image of pin 1 is. So your eyeball over here thinks that the image of pin 1 is somewhere back over here. Now there's not really anything here, and so we're going to refer to that as a virtual image, and later on we'll see some examples of real images where you can actually see the image at the location that the image is formed. Let's do this last bit here. I'm going to remove pin 2, even pin 1. We're going to take our protractor and we're going to line it up at the vertex, is that the correct word, of that angle right there, and we're going to construct a perpendicular bisector. So what that means is get your protractor right there where those two rays meet, put you a dot at 90 degrees, and then just draw a dashed line to represent that. Now really we would not call that dashed line perpendicular because it's perpendicular to a plane. The mirror is a plane. So we're going to call that normal, as in at a right angle to a plane instead of a line. So remember the normal force from back in the day, same meaning, perpendicular to a plane. And what we want to do is we want to measure the angle of incidence, which is this angle right here. We'll call that theta I for incident angle, and the angle of reflection, and measure the angle of reflection, which would be this angle here, which would be theta R. So the incident angle we're going to measure, and the reflected angle we're going to measure. So after doing this one time, we should be able to tell how these two angles are related to each other. Are they the same? Is one bigger than the other, etc.? And after we do two of these, like move pin 2 over here and draw a second set of rays, we should be able to trace the rays backwards to see where they cross. And that's your job. See where they cross behind the mirror. When we do that, we are then going to take our ruler again, and we're going to measure the distance from the mirror, and the mirror plane can extend as far as you need it to. This distance right here from the mirror to the object, we're going to call that SO for object distance. Somewhere behind the mirror, those two rays of light, those two imaginary or virtual rays of light should cross. Maybe something like that right there. The point where they cross is where we are seeing the image, and we're going to measure that distance as well. That distance we're going to call SI for image distance. And so I stands for image, and it also stands for incident. Just kind of keep those things clear. You won't have an incident to image. That would not make any sense. So we're going to measure those two things and see how those compare. So by the time you draw all these rays and do all these measurements, you should have three things figured out. How does the incident angle compare to the reflected angle? How does the image distance compare to the object distance? And then you should see how those reflected rays create virtual rays that cross behind the mirror, and that's where the image is located. And as you're working, please let me know if you need any assistance. I do encourage you to do this with pencil and then go over it with different colors and kind of color code it, especially as you add a second set of rays like this, because it's going to get kind of complicated in a hurry. So color coding things in general when studying waves and optics is a big help.